So we have a correct molecular replacement solution. Now we'll start model building and refining it. So what I want to do first is open it in Qt and delete all of the loops that don't match the density, because those will contribute to bad geometry, clashes and noise. And then add back all the missing side chains, which will improve things, and then do a quick round of refinement. So for the model building, I find it helps to have a word processing file with the sequence in it in blocks of 10. So we will just have a look at that. Oops. So I usually make these files by hand rather than with a script, because it gives me more of a sense of the structure of the sequence. I can also so I'll open the PDB. And Qt will calculate a map. This is a fresh install of Qt, so I want to add in some extras. Okay, so this is my sequence. So this is the PSP28 sequence in blocks of 10 from the initial methionine to the end, and I've made 4 copies. So what I usually do when I'm building is to annotate with highlights things that are correct or missing or whatever, but we won't do that just yet because we're at a very early stage. So the new Qt has this feature curlew for extensions, and a very good one is Oliver Clark's Qt trimmings. So let's install that. And this elaborated add terminal residue, also useful. A lot of these are good, but that's probably a good start. So we see extra bits have appeared. There's actually one thing I want to change in the default for the Qt extensions, which is so I'll just this is the scroll wheel to toggle the map level. Which is off by default, which is a crazy default in my opinion. So I just need to change it. I can't remember the name of it. Scroll active map scroll wheel. There should be a, maybe it's at the beginning of the file. Let's go to the top. Here we go. Set scroll wheel by mouse needs to be 1. So now if I twiddle the scroll wheel, the map contour levels will shift dynamically. So I probably need to reload that. So let's exit and load it again. And and now I twiddle the scroll wheel and the map level changes. So we have 4 copies here. So at the beginning I proposed to edit only the A chain and then copy it. So let's go to C alphas plus ligands, and we'll go to chain B is in yellow, chain A is in orange. Okay, so to begin with, so residue 24 is in the wrong place, and I don't trust it as far as residue 31, so let's delete those. Delete zone from there to there, and the new coot has drawn in some dashes to show we're missing. Anywhere else that looks bad, let's go to the beginning. Okay, so there's actually a missing bit here anyway. This is the alignment, so I can see here that it doesn't really fit the density very well from there, which is residue 46, to 52, so let's delete that. Delete zone there, so 53, there we go. That looks okay. This is towards the end. That's residue 106. That's looks okay. Coming back, just looking backwards through the whole structure now. 80. Oh, actually looks okay. 69. 64. This loop looks okay. Back to here. This loop. Okay, so we're now 43, going backwards down here to 34, and back to 18, and you can see it's following, not brilliantly, but I'll leave it in place, to residue 5 and 4. Okay, so we have now a chain where the worst wrong loops have been removed, and now we could fill in some incomplete residues. Now I usually like to go through these one by one. This will take a long time. I think for this case I will just... So if we just take a look at this rotamer validation, we can see that chain A, all these purple residues are missing atoms. And that proline is a bad rotamer, it's red. So if we do, I think one of these customs is fill in incomplete residues. All molecule. Oh, here we go. All molecule post-molecular replacement fill partial residues. Find and fill residues with missing atoms. Okay. So we can't see them because I'm just looking at C alphas. This is taking a while. So some of those will be in the chains that I'm not building, so in a minute I will just copy chain A to the other chains, which should also remove the missing loops from those chains as well. So this is filling in the missing residues and then doing a real space refinement of those positions to the map. So the current R3 is 49%, and I need to get it down to about 23%. So to find more than 20 points of R factor, just deleting the wrong positions and filling in these side chains should give a few points of R3. So we'll see how that looks. in model building it's best to just do little bits in the map that you can interpret and then refine, and then the map should improve, and then you can interpret more rather than try to interpret things that are difficult to interpret. So if we now look, we see that all the purple is gone because all the missing atoms have been filled in, and there's chain A actually seems to be the best because probably these red bits are in bits that I've deleted from chain A. So now let's fill in chain A. Non-crystallographic symmetry tools, copy NCS chain. We'll take A as our master chain and then copy it. So now every chain is a copy of chain A. Let's look at difference map peaks. 4 sigma. Okay, so is there that loop needs moving. That is maybe a big side chain that needs filling in or moving, and it is. Possibly that tyrosine is in the wrong place. That chain needs extending. Negative difference peaks in the middle of nothing usually correspond to some sort of bad scaling, so we'll just ignore that for the moment. That arginine is in the wrong place, so you can see that side chain clearly wants to come over here. So let's do that auto fit rotamer. No, it wants to go over there. Let's move it over here. Not perfect, but better because it's not causing a clash anymore. If I press O, that will take me to the other NCS copies. So actually in the other copies it is, in the other... Okay, it's not perfect, but it doesn't need to be. So the purpose of refinement is not to, or model building, is not to move atoms to the perfect place, merely move them into the correct position for refinement. So that looks horrible. That is the C-terminus of the protein, and that's some very bad geometry. Let's do real space refinement. So if we look now, that's I don't think correct, because I think it's putting the side chain where the main chain should be going. So actually I think I might just delete that and we'll fix it later. Okay, so I don't want to model build too much now because the next round of refinement will give a better map, so we'll model build into that better map. I can see things that are just obvious fixes, but I'm just going to leave them for now. So that tryptophan could be twiddled, but let's leave it. So let's save those coordinates. Ref max 1, coot 0, save. Okay, so quick coot, and then let's do a quick round of refinement. So I'll call it ref max 2. Input is now the output from coot. Output is ref max 2. Let's do 20 cycles of refinement. Leave the defaults, so it finds the appropriate weights between geometry and X-ray, and we will leave the NCS restraints in place. We won't do any fancy TLS parameters, and we won't look for waters because our map isn't good enough yet. Okay, so this will again give lots of complaints about geometry because the geometry is still terrible. There will probably be there'll be many chain breaks, so we'll complain about those. So I'll pause now and we'll look and see what happens to the R factor. Okay, so just deleting those loops already moved our R3 from 49 to 47.8 in cycle 0, and then refining those complete side chains and missing loops with the one rotamer that I fixed, changed the R3 to 42%. So that's a 6% drop in R3 in one run of RefMac, which is an excellent improvement. And if there was any doubt before, it's gone that this is definitely a correct molecular replacement solution. It's just a question of improving the model. So the next step is to go through the model and manually put in the missing loops, look at how similar the NCS copies are. So hopefully all 4 copies are identical, but I actually happen to know that for this structure the loops are in slightly different positions, so they need a little bit of independent building, or each loop in each copy needs to be looked at separately, and then later on move to adding solvent and using a more sophisticated anisotropy model, so TLS, for the B factors. One thing is that NMR structures, speaking as a crystallographer, tend to have relatively poor initial geometry, so there'll probably be some things like backbone carbonyls that will need flipping. So all of the structure will need to be looked at. It's about 100 residues times 4, which is quite a bit of looking at. So this structure, but this is the hard bit of the structure solution is over, which was the molecular replacement. Now that's complete. It's just a matter of incremental improvements, and the difficult part of the problem has been solved.